Hello and welcome to this course on data visualization with Seaborn. My name is Valentine and I'll be your instructor for this course. This course will follow the following structure, so this agenda. So we'll get started with the learning outcomes of the course, so getting to understand the objectives in this particular learning experience. In addition, we'll also get to learn about what Seaborn is, why we use it, and when we tend to use Seaborn in data science or in data analysis. After that, we'll go through some reading and a quiz, which will go into depth with regards to Seaborn concepts. This will be a self-paced section, so you'll spend about 10 to 15 minutes going through a curated reading that we have prepared that will allow you to fully understand the strengths and limitations of Seaborn. So this is the document that you're going to go through, as well as once you finish that document, you go through a quiz that will assess your understanding of the concepts that will be covered in that reading. Once you have finished that, you will go through together with me. I'll take you through a practice session that will entail going through concepts in relation to Seaborn. So how do you work with Seaborn? How do you write code? We'll go through examples as well as challenges of a document that we have created. So this is a notebook, and a notebook generally is a document that data scientists or data analysts tend to use when it comes to working on projects. So we've curated one that contains concepts in relation to Seaborn. The concepts have examples as well as challenges that accompany them. In addition, we've also provided some solution notebook that will contain generally sample solutions to the challenges that we have provided. So the idea is that you will put into practice those concepts in relation to Seaborn that will be important in any data science or data analysis project, and you will also be in a position to verify your solutions. Once you have gone through the practice work, it's important to also put those skills that you have learned into practice in a real life project. So we've also provided that at the very end. So the idea is that you will go through this project and be able to put into practice those skills. And once you have gone through the project, we've also provided a guiding, or not a guiding, but a solution notebook, a sample solution notebook that will give you an idea of how, or give you an idea of how you could have approached this same project in a different way. So this particular notebook have will have generally just answers to some of the questions that you did come across. So the idea generally is to also just putting into practice what you have learned and be able to have skills, Seaborn skills that you can use in any data related project so that you can become an expert in Python, but now an expert in creating visualizations using Seaborn. So generally, that is what to expect when it comes to the agenda that we're going to be following through. We would understand that the idea is that so far you have some idea of how to use Python programming language. You could be confident in working with variables, for loops, dictionaries, because this particular workshop or this course will take you through the application of those concepts in the context of data visualization. In addition, if you would want to also ensure that your learning experience is quite seamless, it's also important to have gone through some data wrangling course or some data analysis course as well. We have those also provided in our platform, in our channel. And also, you should have gone you should have a good idea of how to use a data visualization library called matplotlib, majorly because Seaborn tends to use that library in the process. But if this is your first time learning about Python, I would highly advise you to go back to learning Python basics or introduction or fundamentals of Python. and going through those mentioned courses before you get to this point. But we'll make sure that even if you still want to go through the course, we'll make sure that we try as much as we can to simplify the concepts for a beginner. So let's get started. So by the end of today, you're expected to have achieved these learning outcomes. So you should be able to create various basic data visualizations using Seaborn, including scatter plots, line plots, histograms, as well as other statistical data visualizations that would come in handy when it comes to communicating insights about data. You should also be able to customize Seaborn plots by choosing themes, color palettes, titles, and labels, as well as analyze those visualizations to extract insights. You should be able to evaluate when to use Seaborn versus other types of libraries or visualization tools, and also be able to understand its limitations, and therefore be able to make informed decisions generally on whether you should use Seaborn or other tools. You should lastly also be able to develop advanced visualizations such as heat maps or violin plots when using Seaborn, or generally just be able to develop those visualizations in an effort to communicate data patterns or insights when it comes to the data that you have at hand. Starting off, what is Seaborn? So Seaborn is a visualization library in Python that you can use to create statistical data visualizations. So within the ecosystem of Python, there are many types of libraries that you can use, and libraries are just chunks of code that perform specific tasks. So there are libraries for performing data manipulation tasks, libraries for reading data, libraries for creating machine learning models, libraries for creating dashboards. But now there are libraries, much more specifically, for creating statistical data visualizations. In the Python ecosystem, Seaborn is the popular library for doing that, for creating statistical data visualizations. And you would use this library having knowledge of also a bit of matplotlib. So this library, Seaborn, is quite popular. And if you want to create informative and statistical graphs, then you should opt to go for this particular library. If you're looking towards just creating a basic chart, or basic visualization without looking in a lot of aspects with regards to the data that you're working with, then a tool or library like matplotlib would be the best example. But if you're looking towards creating advanced visualizations such as heat maps or pair plots, which are statistical visualizations, then you can look towards Seaborn. So it provides a high-level interface for creating informative and attractive statistical graphs. By this, it just means that there are those functions. So in a library, you do have functions which you can use to be able to make the visualizations that you want. So it provides a high-level interface, an easy to use way of interacting with just functions for plotting. It's also particularly well suited for visualizing complex data sets. So if you want to visualize relationships between data and visualize them all at once, then Seaborn is the right tool for that. When it comes to why do you want to go to Seaborn over others, why should you use Seaborn over others? The first thing, it's ease of use. So Seaborn provides a high level interface. What this means, it's able to help you to create those complex visualizations in an easier way. So it generally simplifies the process of creating those complex statistical visualizations easily. It also requires less code as compared to matplotlib, which requires quite a much amount of code as opposed to Seaborn, and we'll get to see that. And for many people who are looking towards getting started with interacting with Seaborn. It's possible you could get started interacting with it without even knowledge of Matplotlib. But again, it's highly recommended that you also have some understanding of the Matplotlib library before going to work with Seaborn, because sometimes you might want maybe to make some customization options, and just having an idea that you can use previously learned functions from Matplotlib can also enable you to achieve what you want. The data visualizations that you would end up getting with Seaborn normally are aesthetically pleasing by default. So if you create a visualization, say for example with a line chart, let's say you want to create a line chart using Seaborn, the end result that you would have immediately, without writing lots of code, just writing just the normal, using just the normal line graph approach using Seaborn, we just give you a really good looking visualization, as opposed to something like Matplotlib, which sometimes looks just a bit more plain. So Seaborn comes with visually appealing default themes that you can play around with, and also color palettes that you can also tweak a bit, and the end result is usually just good looking visualizations without very much effort that you put into. The other bit why you would want to use Seaborn would be, again, statistical visualization, which just would be different types of functions that you can create in order to, say, visualize relationships between variables, or conduct regression analysis, or even create summary plots. And that way you can be able to have a suitable tool for probably data analysis or exploration in your line of work. So generally, when should you use Seaborn? When you want to create aesthetically pleasing default plots without much customization, when you want to visualize statistical relationships, when you want to work with what is called pandas data frames, which when you want to work with pandas data library, which is another library for data manipulation. So if you want to work with that, with the data and the data structure that normally is supported by that visualization, which is pandas, then you could look towards Seaborn. If you also want to create complex plots with ease, then Seaborn comes in really handy. And also if you want also to save time on customization, again, that also becomes a really good tool to use. So I hope you've understood what is Seaborn, why should we use Seaborn, as well as when to use Seaborn. Those concepts are quite important. First of all, understanding what the tool is before actually going deeper into using actually the tools themselves. So the next thing that we're going to do, you're going to take about 15 minutes, and what you'll need to do is to go through the curated reading as well as the quiz that we will have provided by following the link in the description section, depending on the platform that you're accessing this course from. So you should follow that link. It should take you to the Afterwork platform, or you could be able to also download them if the platform that you are accessing this course allows for that. Once you follow that link, if you're an Afterwork member, you'll have access to all the resources, including this link, the reading, the link to the reading, the quiz, the practice notebook, solutions, projects, etc. But if you're not an Afterwork member, we have a sample solution notebook that you can use to go through the examples that we will be going through in the next section. So, but at this particular point in time, just go through this reading as well as the quiz that you see here. And this should give you just a good idea of what really Seaborn entails. Then once you have reinforced those theoretical concepts, then we'll go through the practical practice notebook that you see on your screen that will give you some practical aspects of how to implement Seaborn when it comes to just creating visualizations. So take about 15 minutes. You can pause the video and then come back once you have done that, and then we can continue. All right, so I hope you are able to go through the reading and then the quiz. And now at this particular point in time, we'll go through the practice notebook. And a notebook generally would be that document that data analysts or data scientists normally use. And our focus will be to learn all the concepts that we have come across, all the fundamental concepts that will be important when it comes to using Seaborn for the creation of visualizations. So starting off, open this notebook. If you have the sample notebook, you won't find challenges, but if you want to get practice work, you can just become a member and you can have access to this particular notebook. But generally, the idea is that once you get to this notebook, you go to file, then save a copy in Drive so that you have your own copy. So file, save a copy in Drive, and then it will open a new tab with the same copy, and you can close this one, you can rename the new one. And then once you've renamed the new one, you can make changes, and that way, if you happen to make changes, you will be able to save those changes in that document and have that document again saved in your Google Drive. And you could always go back to the point where you left off at any one point you decide maybe to step off, take a break, as opposed to if you use the original copy of this notebook without going through this step, you will have to rerun and rewrite the code that you need to that you had written again, because it won't be saved anywhere. So starting off, once you have saved a copy in Drive, the next thing that you need to do is to click on connect on the far right, top right, to connect this notebook to Google servers. So this notebook is hosted in Google Drive, and Google has provided an app that allows us to work with notebooks called Google Collaboratory. And we can use now this notebook to, we can actually run code in our notebook, which we will find, and we can run it through the use of Google servers. So that's why we just connect the notebook there to Google servers. The first thing that we're going to do is to install or not to import the prerequisites for this particular course. So we are going to import Seaborn, which you will do using this line, import Seaborn as SNS. Then we're also going to import matplotlib as PLT. So matplotlib.pyplot, which is a submodule in the matplotlib library that has the core functionalities of matplotlib. And we are going to import it. The reason is because Seaborn actually relies on matplotlib. Hence, that's why I was mentioning that you also need to have a good idea of when to of matplotlib. It will come in handy in this course. Import that, and then you're going to also import NumPy as NP. NumPy is a data, it's not a visualization library, it's just a library for performing scientific computations. Maybe you want to perform some conversions, maybe maybe you want to convert maybe a float to an integer, you can use NumPy. If you want to perform aggregation operations such as sum, mean, or max, then you can use NumPy as well. Lastly, we will also import pandas to enable us to perform data manipulation tasks. So if we want to clean our data, if we want to summarize our data using pivot tables, then pandas will come in handy. So let's run this. You won't get that option, that pop-up, if you had saved a copy in Drive. Don't worry about that. If you have, if you get that pop-up, just ensure that you go to file, then save a copy in Drive. Otherwise, you won't be able to save your changes. Yeah. So once you have done that, the first thing that we're going to learn is just the basic structure of how to create a plot using Seaborn. So we are going to learn generally how we can be able to just the two different methods of how we can be able to create a basic data visualization using Seaborn. So the first method that we're going to learn, actually also something else that I need to mention to you, for ease of learning, we are going to just have two types of examples for each concept. The first example will just have just some data that we'll have hard coded that we can be able to use. And the second example that you will get in the examples for each and every different section will have actually a data set that you can implement and you can download and also implement the concept to. So whether it's a bar chart, histogram, you will be able to have a real life data set that you can pull data and be able to create a visualization for. And the idea, by the way, is to ensure that you will be able to transfer those skills in that situation. So let's get started. The first thing that we do is prepare our data sets. So we have two data sets over here that we want to visualize a plot for. So age data set contains just ages. DA salary contains salaries of could be actually data analyst salaries, data analyst salaries. And then once we do that, we use matplotlib to set the size of our plot. So we use the figure function from PLT. PLT, you can see PLT is this, SNS will be this. So we do that. We set it to be 6 dimensions by 5 units. You could always just tweak around with these figures to be able to determine what visualization size works best for you. Then we, once we have done that, then we create a variable called AX, and we equate it to, AX will actually use that to be able to set the size of our visualization plot. So here actually what we're doing, we're creating an object, but don't worry so much about that. Let me just focus on, we create a variable, but then and then we assign that variable whatever that you see here. So we reference SNS. SNS is just Seaborn. So Seaborn, then line plot function, because we want to create a line plot to visualize the relationship, to visualize how age changes with DA salary. The data that we are going to work with first is DA salary. That's what we are going to assign is the first argument. The second argument, on the x-axis we want age. On the y-axis we want salary. We also set the color of our our line chart to be blue and the label to be DA salary. You might also note that in this line, this is how you achieve this particular method. This is how you achieve a line plot using Plotly. This is quite easy, but the only thing is that with Seaborn, as you'll get to see as we get to far complex visualizations, you realize that working with Seaborn will actually be the best alternative. So once we have done that, we set the title using just AX, the object, the function set title. We pass the first argument as the title of the visualization that we want, and also we do the same thing for the style, how we want the title to look like. We set the font name and to be equal to serif, and font size to 15 using this dictionary and this argument. So once we do that, we also set the X label. That's the X-axis title to employee age, and you could also do the same thing with font dict. You could also add it here. The Y label as well. You could also do the same thing to style it. We also add a legend which will display our DA salary, and we visualize the plot. So let's do that. And what we should be able to see is actually the visualization that we want with salary, employee age, age versus salary using Seaborn. All right, so assuming that we also wanted to introduce some new piece of data, so DS salary, so and use Seaborn for that, DS salary. This is the data set for data scientists salary. We set the plot size. Now what we're going to do is introduce a second plot. So which we do that using this line. So the only thing that changes is DS salary as well as for Y, and the rest, and also we update the color, and the same case with the label. We use in our situation over here, again, if you come from the matplotlib background, you'll see that we're also using PLT, which is matplotlib PLT here. We're also using that now instead of using the second approach. The first approach that we used to create to set the titles for, or the X and Y labels using Seaborn functions, we now decide to use just matplotlib, and you can see how we do that. We use the title function, set the first argument as the title of the plot, and the second argument is font dict to have the styles for how we want the title to look like. We also set the X label, which is the X-axis title, the Y-axis label, to the title, and also the not the title, but it's the label. And we also display the legend and also show the plot. You'll note that we also do the same here. So let's run this, and we should have our visualization, two visualizations appear here. And the thing is that we are using a Seaborn plot over here. All right, that's the first method where we just use we just have one visualization, which is what we have here, but it has two plots. The second method would involve understanding this figure. So you have understanding what happens generally. If you want also to create a visualization. So first of all, you have what is a figure container on the outside. This is sometimes in Python, we call it an object. And inside the figure, container, you also have an axis container. And this is also in Python, you can refer it to as an object. So inside the figure object, you also have an axis object. But now you can have many axes of axis objects. So you can have multiple axes inside one figure. That is how you're able to achieve multiple visualizations using generally Python in one particular go. So let's just do that. So we will start off by defining our data sets from scratch, and two data sets, age and DA salary. And then we create the figure object, this figure object, and the axis object. We just want one, so figure object, axis objects. And we do that using PLT, this is matplotlib.subplots function. And then once we have done that, we can be able to use the line plot function that we used from Seaborn. As you can see here, we set data as DA salary and color blue, and label DA salary, and we display our plot. And let's run this, and you should be able to see that is what we have. However, you might notice on the x-axis we haven't set the age. That is something that you can be able to set by using x and y by setting x and y arguments to be able to do that. So by default, for just ease of learning, this is what you could do. But you could do the same. Just set the the x to be age, and you should be good to go. All right, so you could also do the same thing for salary, DS, data scientist salary. You just introduce another plot, still the same figure and axis objects, and then you set the size. But now in the situation over here, we are going to set the axis for now, just the plot that we are working with. So AX, which you could see here. So if we run this, we should be in a position to see our visualization plot. It's the same as previously. Actually, here you could say this is 1, 1, 2. So if we run this, let's see. Yeah, so generally these are two axes, but this actually references this. So here you have two different SNS plots or plots that you plot. But now the functions that we're using, we're actually using functions for the object using the set title and X label, set Y label. So we're using actually Seaborn we're using actually matplotlib for that. We can also introduce I think we can also have multiple plots if we wanted to have two columns with multiple plots for a one visualization. So we can have, let's say, one plot here and another one on the right hand side. So how we do that is we can decide to when we are defining, this is one way. We can also do it a different way. So when you're defining your figure and axis objects, you could define them inside the subplots function where you have 1 and 2. So one row and two, and in one row you want to have two different visualizations as shown, and also you describe the size of the figure as one of the arguments, as third argument. And then you now define the individual line plots. And for each line plot, you could also have, you could also set the title, x-axis, as well as the y-axis, and you visualize it. Let's do that. As you can see, we have now 2 plots. All right, so that's just generally it about the basic structure. So once you've understood that, you should now be in a good position to continue working on the next section. All right, so moving on, we're going to go to get started with bar charts. So the next section will entail creating a bar chart, which is just generally a visualization that presents categorical data with rectangular bars. They could be horizontal or vertical bars, which would be would have their length proportional to the values that they represent. So starting off, we'll start off with just this example: create a vertical and horizontal bar chart that describes the distribution of cake sales for bakeries. So assuming that we have this data set, so we have cakes as well as these are just labels that we can use, and sales for each and every cake. So this value corresponds to this value, this one corresponds to that, 400 corresponds to grape, 300 corresponds to cupcake, and 600 corresponds to chocolate. This is for ease of understanding. That's why we had coding them. Then we create a data frame. Normally, Seaborn works really well with just direct data frames. So that's what we're going to do. We create a data frame, which is just a tabular, it's a data structure used when you're working with the pandas library that shows everything within, it displays it assigns, it actually puts data in a tabular structure where you have columns and rows. So we create a cakes df tabular structure, but we call it a data frame. And then we render our chart. So in our case, we want to create a vertical bar chart. So we use the bar plot function. So from Seaborn to do that, we define data as the first argument in this particular function. We set it as cakes df. We set the x axis of the bar chart to be cakes and y to be sales. Then we tweak and label using matplotlib. So plt goes back to matplotlib. X-ticks will just represent the rotation of the X labels, so they'll be tilted. So at the very bottom of the X-axis, our labels for each and every bar will be tilted 45 degrees or rotated 45 degrees. Then Y label will have sales as the title. The title of the column will have cake sales, and we'll display using matplotlib. So you can see our visualization, how it looks. All right, moving on to the next thing, we might want to create a horizontal bar chart. So sometimes vertical bar chart, this is a vertical bar chart, but sometimes we might want to display a horizontal bar chart. And sometimes you might ask, how do we do that? So generally, what we would do, you see where we had written X sales and Y sales. So this is a vertical bar, this is a horizontal bar chart. So we would interchange sales and cakes. So in our example here, we had sales as Y. So instead we want sales as X and Y as cakes. That's generally it. We just use the same function and set these other labels as shown. So that's what we would get once we've interchanged that. All right, moving on to example 2. We're going to import a data set that we're going to work with. So we use pandas to be able to import or load that data set and preview the first 5 records, which we have here. So this data set contains information about orders that were made and also in a restaurant. On Monday, there was this order. The total bill was $16.99. There was a tip of $1.01. The person that the customer was a female. They did not smoke. They're non-smokers. They made this order on a Sunday during dinner, and it was for 2 persons. So that's the story for the same data set. You can I hope that gives you a good idea. So in order to work with this table and be able to preview possibly a bar chart, which we're going to do, we're actually going to create a bar chart for day as well as the total expenses. So having, let's say, a table that will contain day, Monday to Sunday, as well as the total expenses. On the other hand, it could help us understand which day of the week had what expenses. So to be able to work with that kind of data, so we are going to create a summary table, which will help us, which will help summarize that particular piece of information. Then we will use the summary table to create a visualization, which is a bar chart. So to create a summary table, we can use a group by function. So we select the column that we want on the left, which is day. We set as index to false to be able to have a table that we can work with. And then we use the aggregate function, and inside it we pass an argument, which is just generally a dictionary that has a total bill is a key, and the value is np.sum. This is where numpy comes in. So on the right hand side of the table, we have the total bill and the sum of the total bill for each and every day. And the output of that we'll get as follows. We have Friday, Saturday, Sunday, and Thursday. And the bills, we see Saturday had the highest, 1,700. So once we have done that, now we can visualize our data set using this particular table. So we do that using the SNS or Seaborn bar plot function, and data, we set that as that. We want day to go on the x-axis and y total bill, and we tweak and label our visualization and display it. And you can see how it looks like. Okay, all right. At this particular point, work on the challenges, bar chart challenges. And once you have done that, verify your answers using the challenges section, the solutions we've provided in the solution notebook, and then we'll continue. All right, I hope you were able to get through that. The next thing that we're going to go through is histogram. So a histogram helps us to visualize distribution of data over a continuous interval, a certain time period. So for a histogram, so what we are going to do is to use Seaborn to create a histogram. So create a graph that shows the distribution of the following data set. So be frequency distribution for this data set, height. When we are working with histograms, we also can set the bins that we want, which will help us be able to visualize our data set much more easily and effectively. So these are the bins that we can have. So we want one bin to come from 150 to 155, 155 to 160, etc. So we use the Seaborn dist plot function to be able to create a histogram. We set the first argument as the data that we want, height, and bins is what we have set here. And we tweak our and label our chart, and then we display it. So we should be able to visualize our plot as shown. So this is a histogram that gives us an idea that majority of the points actually lie between actually lie on this other side, on the left side of this particular scale. We can also use now a real life data set. So assuming that we had this data set, a FIFA data set, so we create a histogram to display the frequency distribution of the overall variable in the FIFA data set. So we load it. What we want overall column is like the rating. Yeah, tells us how good the player is. Lionel Messi had 94, Cristiano 94, etc. It gives us some more information about it. So what we're going to do is prepare that data so we can simply get that data, the data that we're interested in, the overall variable, and store it in overall. And then we can also define our bins and then render our plot using Seaborn. We set KD to true for the reason that we want to display to display our visualization as we would want. And then we tweak and label our data set and display that. as you'll get to notice, when we set KDE to true, we get this line, which helps us also understand how our our distribution generally looks like. Is it normally distributed, skewed to the right, or skewed to the left? That that line helps us to be able to do that. All right, at this particular point, work on the challenges and then verify your solutions using the solution notebook. Moving on, we'll go through now line chart, how we can be able to use line charts using Seaborn. So we can use line charts to display quantitative values over a continuous interval or time period. The idea is to understand trends, patterns, and fluctuations in the data over time. So starting off, we have this question. We want to create a line graph to describe the trend of car sales during the year 2020. So this is the data that we create. So we have this one that contains months, this other one contains sales, and these respective, each let's say for instance January, and this particular value correspond. The same case here. And we also create a data frame. We mentioned again, Seaborn works really well with pandas. So once we have done that, we can then set the size of our plot using matplotlib. If you want, then we can use the line plot function from Seaborn to be able to define how we want to display our line graph. So in our situation, the first argument is sales df, that's the data frame. The x-axis, we want months, y-axis, we want sales, and we also have a marker. We set the marker to is an O, which should just be dots within our graph. Then we display we tweak and label our visualization and then display it. There you have it. Right, moving on, create a line graph to describe the trend of gas price in the UK, USA, and France since 1990. So first of all, we load the dataset, the gas dataset. And you can see that dataset contains just information about gas prices for different countries. So we want UK, USA, as well as France. We prepare the dataset by simply getting the year values, and we use the to list to have a list of values for year. We do the same for UK, but UK we don't need to list. Do that for US prices and France prices. Then we have this in a data frame that we can work with, which you can see here. And then we can be able to do this. But you could also skip this step. This is not necessary. You could actually plot, you actually define the you can actually define directly to this particular table, just for ease of understanding how we can be able to do that. So we use line plot as an line plot, gas data equals gas df, then x years, y equals UK, and same case here, line plot years, y equals US, line plot y, x is equals to years again, which is what we wanted, the x axis, and y, the y axis one France. We could also actually define also the markers that we want, like we in our previous situation we had a marker here. Could define how we want it, maybe an x, or but here by default to be just 0. So we do that. We don't need anything here, and then we tweak and label our visualization and display it. So this is what we have. Actually, when we don't define our marker, we won't find any dots. But if we define it, let's say for instance, marker 0, so or 0 O, we'll be able to see dots in our visualization, as you can see. All right, work on the challenges and then come back and we'll continue with scatter plot. All right, moving on to scatter plots. Sometimes you might want to check if there's a relationship between two different columns, numerical columns, or variables. So how can we do that? We can use a scatter plot. and we can create a scatter plot just using Seaborn. So let's go through the first example, create a scatter plot to describe the relationship between the two variables that we have here. So we have this variable x data and y data, which have these pieces of information. For x data, we have that, and like y data, we also have that. So we create a data frame for that. And then once we have done that, we can just set the data frame data as the first argument. And then x, we define what we needs to go on the x column as well as on the y column. And then we tweak and label our data, our visualization, and display it. As you can see, in our situation, we have this data set and um and there's a relationship between those two variables, because how we interpret this is that if there's a diagonal, if the points are spread across in a diagonal form, then those two variables will be highly correlated, which means that the values, as values of one particular variable change, the values of the other variable also changes. This can be as shown, or like that extreme, or even a slightly extreme, but that would be slightly weaker than what we have here in terms of a correlation. It could even be on this other side where we have a negative correlation if points come from this side and they're moving towards this side. So yeah, so that means x and y have a positive r, they do have a relationship, which is a positive linear relationship. All right, moving on, let's work on now this particular, use this data set. So create a scatter plot to determine whether population and income variables are highly correlated. So let's load the data set, which we can see here. We have country, year, life expectancy, income, population, and continent. We want to determine whether the population variable and income variable are highly correlated. So we're going to use a scatter plot and check on whether we have that pattern, that diagonal pattern, which would describe that those two would tend to tell us that those two variables are highly correlated. So we define first of all the size of our chart, then we use a scatter plot function from Seaborn, and we set the data set that we want, population and income. So on the x-axis we want population, y-axis we want income. And we also introduce a third variable, which is continent, that will which is hue, and a third argument, which is hue, that will just provide it will give us some distinct aspect with regards to our visualization. Yes, we might decide not to use it, but it will tell us like whatever point, which point is which point through the use of colors. So we also set, and we tweak and label our data set and also display it. So if I run this, I should be able to see that these are our points. But I can also remove this if it's a bit confusing, because the points just tell us like what points are which country, like which continent they are, like Asia here, Europe over here, Africa down here, income, which is quite low. It can give us just a few more insights. Americas, this one. There's population, yeah. So but generally that gives you a good idea of what points, which continent they belong to. So we are classifying just the points based on continent, but the idea here is that we have a scatter plot, and we had mentioned that if we wanted to, if we wanted to conclude that two variables are highly correlated, would either have a diagonal, the points would be spread out diagonally, or across different directions. So it's whether this side or this side. In our points, we don't have those points. Many of those points are not spread out in that manner. So in our case over here, we can say that those two variables, that's population and income variables, are not highly correlated. At this point, work on the challenges and then verify your solutions, and then we can continue to pair plot. So sometimes we might want to have multiple visualizations, scatter plot within one particular visualization. So we want to, let's say we have multiple variables within a data set. aside from, let's say, population and income, maybe you want also to check life expectancy, which is also a numerical variable. We also want to check for that, whether life expectancy versus income, or life expectancy versus population, or population versus income. We want to visualize the relationships in one visualization. Then pair plots does come in handy. So we use a pair plot to get the relation between each and every variable present in the data set. So starting off, we will just create 3 variables and be able to see the relationship between all the 3 of them using a pair plot. So we set our data for the 3 variables. We create that data set. We create a pandas data frame for using that data set that the 3 different data sets, lists. In Python, we call them lists. So we use them to create that data frame. Then we use pair plot function to create a pair plot for that. And let's run this. And as you can see, this is a pair plot. It's just one plot, but it has multiple pieces of information. So we have multiple scatter plots. So we can see here. And X, as you can see on the far left, we have the variable names, and same case with the bottom. So X, this visualization, and Y. So X and Y, the relationship, the scatter plot for that is represented by this. The same Z and Y, the scatter plot for that is this. For those 2 variables is this. X and Z, the scatter plot for that is this and this. Y and X, the same case here. So you just have a good idea of what variables you have. And honestly speaking, as you can see, all of them have that diagonal relationship that we are talking about. Like points are positioned in that manner, where points come from one particular point and they're moving towards the other end in a diagonal format, and in a diagonal way. So in such a situation, all those particular variables are actually highly correlated. You can also see these histograms which have been created, which actually help us to understand the distribution of the data that we are working with. And sometimes this can be important when we also want to determine whether the data set that we are working with is in a format that can be, is in a proper format for algorithms, especially when we want to build or train machine learning algorithms, more specifically for linear regression. If we want to create a linear regression machine learning model, this information, histograms, comes in really handy, because such models have the assumption that the data set that you're working with has the variables have normal distribution. Like for example, in our case over here, this is not a normal distribution. The same case to this other one here. So in that situation, you need to apply normalization techniques for that particular use case. So, but for now, we are not really interested in that. We're just interested in learning how to just creating a pair plot. All right, moving on to the second example, where we have a data set. We might want to create a pair plot to determine which variables are highly correlated in this data set all at once, like pop. And this is where the beauty of just working with Seaborn comes in. You can see the code that we need to do that to help us be able to answer this question is over here. This is what we have. So first of all, we read our data set. We just explore it to just understand how it looks like. And then we just render and visualize the data set that we are working with, and boom, we have a plot that we can work with. And you can see the variables that have some correlation. This does have some correlation, but really weak correlation. That's life expectancy and income. We can see that the higher life expectancy, as the life expectancy increases, income slightly increases. The same case, actually, it's the same that's being displayed here. I think that's the only visualization that we can say that there is some weak correlation between those variables, income and life expectancy, as opposed to life expectancy and year, or life expectancy and this other variable, population. All right, that's it. Work on the challenges, and we'll be back in a few. Remember to verify your solutions. All right, so once we have done that, the next thing that we're going to learn is heat maps. Now, a heat map is a visualization that helps us to represent individual values as colors. So in our situation over here, assuming that we have this idea, we also wanted to understand to what extent are these two variables correlated. So we might want to assign a number to this particular um, the relationship that we have here, maybe a 0.1 or 0.2, like just the number. We can use a heat map to be able to create such to be able to display that particular number. But you can use a heat map for any sort of visualization, but it's usually applicable um, when it comes to working with what are called correlation values, which are values that we can assign to the strength of the relationship between variables. Like, for example, in our case, year versus life expectancy, that would be a 0 because it's just flat. So that would be a 0. But in our situation over here, we could have this as maybe 0.2, and we could have something else as maybe, but correlation values, they usually range from -1 to +1, and values between 0 and 1, +1, that is, usually are, it means there's a positive correlation, like, as values of one variable increase, the values of the other variable also increase. But if it's a correlation value of between -1 and 0, it means that there is an inverse relationship. As values of one particular variable increase, the other one has to decrease, but it depends again. But if it's close to -1, it means that the other one decreases drastically. So yeah, so let's just see how we can be able to work with heat maps. So going through the first example, so we have these 3 data sets that we had created earlier, and we created a data frame for those particular data sets, that particular data data frame. So once we have done that, we create what is called a correlation matrix, which will just be a table with values, and we display that table with those correlation values. So this is actually what we had mentioned earlier. Like, for example, we assign values to each and every relationship in this particular data set. So for example, for x and x, that's not doesn't make sense, but for x and y, we have 0.98, which means that these x and y are highly correlated. They're almost 1, so it means if it's almost close to 1, this is a correlation value. If the correlation value is close to 1, then it means that those two variables have a strong positive relation. And remember, the correlation values, they usually range from -1 to 1. 0, it means if values are close to 0, it means they don't have any correlation at all. But yeah, so these values just help us understand that the correlation between x and y is 0.98, and it's actually, if you compare it to the correlation between x and z, this is actually stronger than this. And if you are to show that in a visualization, let's say not even use a scatter plot for that, x and y looks like this, and x and z looks like this. So you might not be sure which one of these two is highly correlated. It's actually much more strong, but based on our data, we actually have this 0 this is 0.98, and this is 0.92, which actually means that this one is actually highly correlated. So this table gives us a quick idea of the correlation values, and if you wanted to visualize that in using a visualization with color, then we can use what is called a heat map. We just pass that particular table to our heat map function. We decide to annotate it to have now the values also show up in the visualization, and we can define the minimum value for that, for the values that we want. So the minimum values will be defined by a color that is on one particular range far end, and another color on the other end. For Vmax is the color that will be also on the other end, and we display that in our visualization chart. And as you can see here, we have 1 as one is the values that have higher correlation. So our visualization over here has values closer actually to this particular end than on this other end. So you can know even that 0.93 is lesser. It's actually a bit darker than 0.98, which means this is actually much more stronger. Example 2, we can also do that for the entire data set that we import. So let's do countries, import this one and create a correlation matrix. And we render that. Just almost the same. And we can see here that we have values closer to one over here, which is quite white, is what is represented here. But we can see that 6, 8, these two values, this life expectancy and income, which is the same, income and life expectancy, have a higher correlation as opposed to these other ones. The relationship between population and life expectancy, same case with population and income. All right, work on the challenges and then we'll come work on the last bit. All right, moving on. The next thing that we're going to go through is box plot. So a box plot would enable us to, would actually help us be able to visualize outliers as well as the distribution of variables. So starting off, we're going to go through the process of creating a box plot using Seaborn. So first of all, we prepare our data set. This is just for learning purposes, hard-coded data set, but there are outliers here. So we just don't know which ones are. And in the context of creating box plots, outliers are those values that are far away from a majority of the points. So in a data set, in our situation over here, we would have points which reside between the 50, we reside between the 25th and the 75th percentile as points which are just normal. So points which reside actually within our points within that particular range, like from the bottom, we have the 25th percentile and the top 75%. The points within that range will be normal. The points which appear outside will be outliers, will be treated as outliers. So we do the same x height. We set the height. We can even actually not use this, but for ease of understanding, box plot, we just say that height, we want that to, we set the data set as x as the first argument in our box plot function. Then we just tweak and label our plot and display it. So this is what you're going to see, just an easier way of being able to display a box plot. So you can see there are 2 points which are here around 140 something, which are actually outliers. An easier way of just visualizing outliers. All right, the next thing that we can do is visualize outliers now within a data set that we have. So let's load this data set that contains beer servings, spirit servings, contains quite a number of them. Beer, so country, beer servings, spirit servings, wines, total, blah, 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 blah. I think Afghanistan, we have this. I think okay. All right, let's continue. So Albania, but I think in some Muslim countries you they don't actually, or is it maybe you don't take alcohol? Could be the reason why we have 0, 0. But yeah, or even could be maybe the data was never recorded or anything of that sort. But yeah, but generally, once you've understood the data set, how it looks like, so we want to create a box plot for beer servings as well as spirit servings to understand the plot for this particular case. So to understand the outliers and also the distribution. By the way, in this other one, the distribution, our data set were actually, most of the points lied between this particular section from 90, 95, 92 or to 115. Yeah. So let's create a box plot. We set data to or the first could be x or data, but it's the first argument as drinks df. That's the data set that we want. By the way, we are visualizing all the visualizations, all the numeric ones in this case, but we will be able to see, and we orient our box plots to h. So in our case over here, this was vertical, but we can flip it by setting this to h, and we tweak and label our visualization and display it we can change this to just say just a box plot of all servings, which you can see here. We have numerical variables, and we can see actually wine servings had um, lots of outliers. But for beer, we didn't have outliers, but spirit servings, we had outliers. And you can see even, beer servings, the points in here were much more distributed than spirit servings. And wine servings were less, which, well, most of the points were less distributed. Here we had some outliers, quite a number of outliers. But for total liters of pure alcohol, we had little, very little. All right, so work on the challenges and then verify them, and then we'll continue from there. So once you've finished working on the practice workbook, the next thing that you're going to do is go through this project, data visualization with Seaborn project, and this will allow you to put into practice those concepts that you have gone through or you worked on. So being able to work with Seaborn to create such visualizations. The idea is that you should be in a good position to be able to even answer research questions using Seaborn and be able to create reports that most of the times data analyst or data scientist would normally end up creating. And that's basically it. That would be it for this particular workshop, generally, or course, so you may call it. If you have any questions, feel free to ask them in the comment sections, or even just leave comments about what you would want us to create next time. This is one of the many courses that would come in handy. If you want a recreation or recreation of, again, for us to create a different course that will have different practices, exercises, feel free to also ask that in the chat. That will be also available to afterwork members for free if you are an afterwork member. And all the best in your learning journey. And the next steps, hopefully we'll see you in another data visualization course, or maybe another Python course, such as working with Plotly, data visualization with Plotly. All the best in your learning journey.